Example 1, Jake's icon. Jake created a simple game on his computer and shared it with his friends to play. They were instantly hooked, and the popularity of his game spread so quickly that Jake wanted to create a distinctive icon so that players could easily identify his game. He drew a simple sketch. From the sketch, he created stickers to promote his game, but Jake wasn't quite sure if the stickers were proportional to his original sketch. Is Jake's sticker proportional to his original sketch? Watch the video and take notes to answer the question. So here's Jake's picture. Here's his original sketch, and here's a picture of the sticker that he drew. Zoom in just a smidge so we can see those measurements a little bit better. So in order to see if they are proportional, we need to see if we can find a scale factor or a k-value that relates our original sketch to our sticker. So we're going to start with the original and see if we can find a number that we can multiply everything by to get the corresponding length over here. So to do that, I'm going to create a table. I'm going to zoom back out just a smidge. All right, so I'm going to compare my original sketch to my sticker. So I'm looking for a corresponding side. So if I look at this side, which is 1 inch, over here, I'm finding the one that's in the same position is 2 inches. So I'm going to kind of work clockwise. So my next one is 1 inch. And if I work clockwise here, this is 2 inches. Go down to the bottom here. So 0.75, which I know is 3/4. Go around here, 1.5, which I know is 1.5. And then my last side, which is 7/8. And then this side, which is 1 3/4. So now I have a table, so let's go back to what we know about tables. To decide if a table is proportional, we take our y value divided by our x value. All right, so row 1, we have 2 divided by 1, which is 2. Row 2, 2 divided by 1, which is 2. Row 3, I have 1.5, or improper fraction 3/2, divided by 3/4. So to divide by my fractions, I keep, change, and flip. I notice I have 3's on these diagonals, so I can divide both of those by 3 and they become 1. So then I have 4/2, which simplifies down to 2. And then row 4, 1 3/4. Let's see, 4, 5, 6, 7/4 divided by 7/8. Keep, change, flip. Have my diagonals are both divisible by 7, so they leaves me with 1s. 1 times 8 is 8. 4 times 1 is 4, which is 2. So because each of these rows came out to the same k value, we would say that yes, Jake's sticker is proportional. So I'm going to go up here and write my answer because I'm out of room. Yes, Jake's sticker is proportional. All right, so let's get some steps to help us check for proportionality in our scale drawing. So our first step is we're going to record, let me turn me instead of the paper. All right, so we're going to record the lengths of the actual drawing, or we'll say object or picture on a table. So this is creating our x value. Once we've done that, we're going to record the corresponding, which means in the same position, corresponding lengths of the scale drawing which is the drawing that's the different size on the table. And this is creating that y value. And then our last step is to check for proportionality, or for a constant of proportionality. And to do that, to find that k value, we do y divided by x. So our key idea here: the scale factor can be calculated from the ratio of any length in a scale drawing to its corresponding length in the actual picture. The scale factor corresponds to the unit rate and the constant of proportionality. So know that these things are all of the same. Scaling by factors greater than 1 enlarges the segment, and scaling by factors less than 1 reduces the segment. So greater than 1 enlarges, less than 1 reduces. I would probably copy those parts that are underlined in your notes.